Who recognizes what this pattern is? This is one of the patterns that we learn from in our factoring unit. Who remembers how to factor that down? You got two terms. They're both perfect squares and it's subtraction. Anybody remember how that factors? You're going to go ahead and make your two parentheses. All right, what do we multiply to get this 9x squared? What'd you say, Juan? 3, yep, 3 times 3. So you're going to put a 3x in the front of both. And then what do we multiply to get 1? There's only one thing that can multiply to give you 1, and that's what? 1 times 1, yep. And then 1 has to be addition. The other one has to be subtraction. All right, let's look at this one here. You have A, B, C. You're going to make your X. At the top, you take A times C, which would be -6. And B is -5. So we need two numbers that would multiply to be -6 and add to -5. Glaudy, you don't have to do, Glaudy, you work on your tests. Yeah, you work on your test, and then you can watch this later. But you need to finish your tests. Okay, so what are your numbers that would multiply to be -6 but add to a -5? Feel free to look at your multiplication chart if you need to. So we need two numbers that multiply to be -6 and add to a -5. Any ideas on what our numbers would be? -6 and +1. Go ahead and make your box. So your 2x squared would go here. C goes here. And then the other two squares. Can you hand her a test? You have a test to take. Is a -6x and a +1x. So now you're going to take out your GCFs. So for these two squares, so go ahead, take out your GCFs. So I can take out a 2x. That would come out in the front. And then for these two squares, I could take out a 1. And it's going to be positive because it's touching a positive. And then here, that would just be an x. And here would just be a 3. But it has to be a negative because it's on top of a -6. So it would factor down to 2x plus 1 times x minus 3. And that would be your answer. Factoring is one of those things that just never goes away. All right, so now let's take out your new note packet. So we're in the second half of chapter 12. And let's go ahead and look at page 1 in your new note packet. All right, so there are 3 different types of quadratic equations you can have. Remember that this word root, this showed up on your last quiz. What does that word root really mean? It's on the board if you don't remember. Wait, is it on the board? Yeah. What does the word root mean? X-intercepts, good. So there are 3 different types of quadratics you can have. It's possible to have 2 x-intercepts, or you can have 1, or you can have none. Okay? It is impossible for a parabola to have 3 x-intercepts. The most you can have are 2, you can have 1, or you can have none. So I want you to look at this. This is already graphed. Where does it appear that this graph crosses the x-axis? What are the 2 solutions? So what does this point look like? What is x equal right here where I have my red cursor? -1. And then what about over here? What'd you say, Alan? 5, yep. So your solution, the x-intercepts would be -1. Oh man, I can't get my pen right. Okay, there we go. -1 and 5. So therefore, the solutions would be at -1 and 5. So you can call it a solution, which is the same thing as an x-intercept. It could also be called a root, or it could be called a 0. So you need to recognize that all 4 of these words mean the same thing. And I'm not sure how it will be asked when you take your next quiz. But all 4 have the same meaning. All right, let's go to page 2. So let's go ahead and graph this one. So first of all, this is in standard form. So A is 1, B is 6, C is 8. Go ahead and find the axis of symmetry. Pick up your calculators. Find the axis of symmetry for this question. So, yep, go ahead and figure out where is that axis of symmetry for this graph, because we're going to graph it to find our solutions. So we would take the opposite of B, divide that by 2 times 1, which would be -3. So write x equals -3. That would be your axis of symmetry. So I want you to put that -3 in the middle of your table. And then you're going to look at the numbers around -3. So if -3 on the number line is right here, what are the numbers around -3? So we're going to pick the 2 numbers to the left and the 2 numbers to the right. So our 5 numbers that we're going to substitute in this equation, these are our 5 numbers. So I want you to pick up your calculator and start typing these numbers into the equation. And when you type it in, so your equation says x squared plus 6x plus 8. So I want you to put parentheses squared plus 6 times parentheses plus 8. So pick up your calculator. Start off with -1. Put it in here. Whatever you get for -1, you should get the same thing for -5 because it's symmetrical. So you're going to take these 5 numbers and put it into this equation. So everybody do that. Pick up your calculators. Start getting your 5 y values. Oh, it's the same as x-intercepts. We almost finished for today. This is the hardest question. So I think you all got, for -1, what did you get? 3. Who got 3? All right, and you should get the same thing for -5. All right, what about -2? 0. Anybody else get 0? So what other number should you get 0 for? -4. And then your vertex, your y value, what did you get? +1? -1. All right, so let's go ahead and graph these points. So -1 up 3. Oops, yeah. And then -2, 0. -3, down 1. -4, 0. -5, up 3. So this will be my graph. So now that you have your graph, where are your x-intercepts? Where does this parabola that you just graphed, where does it cross the x-axis? What two x values? Let me zoom in. -4 and -2. So we call that our x-intercepts. And another word, as we just talked about for an x-intercept, is your solution. Now we could have factored that to get the same. So we're going to talk about this part of 12B is what are the different ways to find the solutions of a quadratic. So one method would be to graph it and see where it crosses the x-axis. The second method will be to factor it, solve them. And the third is the quadratic formula. I did leave a question blank. Where is the vertex of this parabola? What's the lowest point of my parabola? Juan, what's the lowest point? Yep, -1. And then what's the x value of the vertex? So this point here in the middle is my vertex, and that would be at -3, -1. Okay, so I want you to look at this one here. This is called a double root. Whenever you only see one x-intercept, we call that a double root. So in this graph, let's put a point right here. That's my solution. And what is the x value of that red dot? What does x equal right there? 4. So my x-intercept is at 4, which means my solution is at 4. So when a quadratic has only one real root, the root must be on the x-axis, and it's also going to be the vertex. So anytime that happens where there's only one solution, that means that that point is the solution, is also the vertex. And we'll talk about this later, how the factor form would be, but the factor form would be squared. And we'll talk about how to find that actual factor later. All right, there's only one more question for today. And that's just looking at this graph. When you look at this graph, what do you notice about this parabola? This is my x-axis right here. Is that parabola going to cross through that x-axis? Does it cross through it? No, it doesn't, and it's never going to. All right, when that happens, that means you don't have a solution. There are no x-intercepts, which means there are no real solutions. All right, any questions so far? I'm going to go ahead and pass out homework 1 so that you can start working on that. And this homework is due on Wednesday. I'm also going to call you up individually so I can put in your homework points